You guys ready for Pi Day tomorrow? Have you made all the party arrangements that you need for Pi Day? I can give you some ideas, because I'm sure you're all going to celebrate it. Why wouldn't you? There's nothing else tomorrow that'll preoccupy your mind, is there? Nothing as important as Pi Day? There's something tomorrow, some kind of an insignificant small thing. What is it tomorrow? Prom? Is it prom tomorrow? Some unimportant event in your lives? Okay. This problem here. Y equals x squared. A lot of you struggle, not with this particular question, but in general, a lot of you struggle with the idea of an inverse back on Unit 4. The first thing you ought to think of when you see the phrase find the inverse is you switch the x and y. Does that sound familiar at all? So it'll be x equals y squared. But then you need to put this back in terms of y equals, in terms of x. You need to get y by itself. So there's two things I want you to think about here. And they're not on your phone. The first thing I want you to think about is what I just mentioned. Not on your phone. When you see the phrase find the inverse, what's the first thought should pop in your head? Switch x and y. Okay? The second, equally as important, you should be thinking of is what is the opposite of squaring something? Squaring, and this is where I think a lot of you are confused on the test. Most of you knew to switch x and y. That wasn't the problem. But a lot of you didn't really understand the idea of an inverse. What's the inverse of squaring? Square rooting. If I'm asking you to find the inverse of this equation, shouldn't your inverse have a square root in it somewhere? Right? And I don't think a lot of you realize that back on the test. The inverse equation should be the exact opposite of what you started with. The opposite of squaring is square root. Both sides. So you end up with y equals the square root of x. Okay? What undoes squaring? Square rooting. That's why this is the inverse, because the square root undoes squaring. Here's what we're studying now though in Chapter 5. Exponential. This equation looks a lot like that equation, except the variable is an exponent, so it's exponential. We, I think, can get the first step of the inverse. How do you find the inverse of this? X equals 2 to the power of y. That's the first step. Well, that's what we need to talk about. That's where we are right now. What's the only reason that I use the square root right here? Because it's a power of 2. The only time you use a square root is if you're trying to cancel a power of 2. Are we trying to cancel a power of 2 here? Now, just a quick question. What if this had been a power of 3? You would use a cube root. What about a power of 4? A fourth root. So, were we trying to cancel y right here? What were we trying to cancel? The exponent. Okay? I want you to really get this drilled in your brain. If it's an exponent that you want to cancel, what do you use? A root. In this case, if it's an exponent you want to cancel, you use a root. Are we trying to cancel the exponent? If we cancel the exponent, y disappears, and that's a problem. We want to have y there. What is it we're trying to cancel? And what is 2? Here it was an exponent. What is it here? It's not an exponent. It's the base. You guys following?
Yeah.
Okay. Initially, most students say, well, just use some kind of a root right here. But what do roots cancel? Exponents. We're not trying to cancel that exponent. We're trying to cancel the base. Okay? So, The title of the lesson is Logarithms. Okay? I need you to remember this phrase for the rest of your lives. I'm going to ask you about it 20 years from now, if I can track you down. Logarithms cancel bases. Logarithms cancel bases. Okay? You need to keep these two things straight. What do roots cancel? Exponents. We're not trying to cancel the exponent, we're trying to cancel the base. So what do we have to use here? Logarithms. What do logarithms do? They cancel the base. Why would we want to cancel the base? Okay. We're trying to get y by itself. Why is an exponent true or false? True. It's only an exponent because it has a base. True or false? If the base weren't here, would that be an exponent? So this is only an exponent because the base is there, right? If we could somehow wipe out that base, would this be an exponent any longer? It would just be y. Do you see why we're trying to cancel that base? What cancels bases? Logarithms. Now, it's not quite as simple as just using logarithms. What I was trying to say earlier, if I wanted to cancel an exponent of 4, do I use a square root? Use a fourth root. Okay? You have different kind of roots depending on the type of exponent, right? You follow? The same thing is true of logarithms. You have different kind of logarithms depending on the base you're trying to cancel. Okay? There's not just one logarithm that cancels every base. Just like there's not one root that cancels every exponent. Okay? This is how you would write this. I want you to leave that blank for just a second. Log, and then just below it with a little teeny number, I want you to put a 2 right there. And then put this expression, 2 to the power of y. This little subscript tells you what type of logarithm you're using. It's just like the index of a radical. This tells you it's a fourth root, right? This tells you this is a logarithm. This is called log base 2 if you were to read that out loud. Log base 2. Why do you think I chose to use a log base 2? Because I'm trying to cancel a base of 2, right? Okay. What do logarithms do? So that logarithm is going to cancel that base. Well, if the base isn't here anymore, then that's not an exponent any longer. Okay. But this is an equation. If you do something to one side, don't you have to do it to the other? So you've got to do the log base 2 of x as well. You've got to do a logarithm on both sides, just like you have to square root both sides of an equation. So what we end up with is y equals the log base 2 of x. That's the inverse of this. Yes? That's just how it's read, log base 2.
If you have a base of 3.
Yeah, so if this had been a base of 3 right here instead of a base of 2, then I would have used the log base 3. Yeah. So just as a quick little thing here, what's the inverse of squaring? Square rooting. What's the inverse of an exponential? Logarithm. Let's go backwards. What's the inverse of a square root? Squaring, right? What's the inverse of a logarithm? Something with a base, an exponential. Okay? They have that backwards relationship. Okay? What do logarithms do? They get rid of bases. Okay? They cancel bases. So, this is how your homework starts. Rewriting logarithmic expressions.
So the first thing your homework would ask is it's going to give you some kind of an expression or an equation that's written in what's called exponential form. Technically the exponent isn't a variable, but it's called exponential form because it has an exponent. But the task here is to rewrite this into logarithmic form. Logarithmic form has no exponents. Okay? If you're writing this in logarithmic form, it can have no exponents.
So right now the problem is this exponent. Yes? But it's only an exponent because it has a base. You follow it?
Yeah.
If this base weren't here, would this be an exponent any longer? No. So what cancels a base of 3? So you would write this as log base 3 of 3 to the negative 2. But then don't you have to do a log base 3 on the other side? No, this is all by. What does a log base 3 do? Cancels out base of 3. So then it just becomes negative 2 equals log base 3 of 1/9, and that's the answer. Yep. There's no more exponents anymore, right? So this is no longer exponential form, it's logarithmic form. How do we know to use a log base 3? Is that base 3? So try. Go ahead.
It's like 12.
Yep. Yep. Try that one. 5 to the 3rd power equals 125. Do you remember seeing logarithms on the ACT? There weren't any? Oh, that's a shame. They're used all over the place, though. I mean, in chemistry or physics, have you guys talked about pH? One of you have talked about pH in your science and chemistry classes? Come on! In what context did you talk about pH? Just how to find the pH? Did they talk about logarithms at all? What? That's how you find the pH. Oh, the little litmus paper? Or whatever it's called. Oh, okay. Well, that's how you find the pH is using logarithms. That's not the only thing you use logarithms for. It's one of the things. They're pretty useful. Turn to the person next to you, see what you got.
I know, I looked at mine on the where did they get that from? I've been writing
So this is where I started. I did a log base 5 on both sides. And then the log base 5 canceled that base of 5. So 3 equals log base 5 125. Technically, no. Now, there was a good question that was asked. I want to make sure that I don't forget to talk about this. Is there a difference between this and this? If I asked you to take the square root of 9, would you write it as this? Why not? Square root is a function, right?
Yeah.
You have to put things inside of a function, don't you?
Yeah.
The logarithm is a function. You have to put things inside of it. Okay? That's why you have to write it like this. This is no good. Yeah? This is good. This is no good. Right here, you're not taking the log base 5 of 125. Okay? So it doesn't go in front. That's why I put the parentheses there to make sure you know that this is inside the logarithm because it's a function.
So the logarithm always has to go in front.
Yeah, whatever you take the logarithm has to go in front. You don't need parentheses. I always write in parentheses. You don't need them. Nope. Okay. If a logarithm cancels a base, you guys, what cancels a logarithm? A base. Let me ask that again. If a logarithm cancels a base, what cancels a logarithm? A base. So we have to go the other way now. We've got to rewrite it in exponential form. I'm going to give you something in logarithmic form. You've got to rewrite it in exponential form. And by the way, this is not just practice for practice sake. The methods we're practicing here are going to help you in lesson 5-7 when we start solving logarithmic equations and solving exponential equations. So this is not just, hey, this is kind of cool stuff. This is preparing you for something else. So write that down. Log base 2 of 8 equals 3. Log base 2 of 8 is equal to 3. The problem here is that they know logarithm. If you're going to write this in exponential form, there can't be any logarithms. Exponential form has no logarithms. It has a base and an exponent. That's exponential. So, what cancels a base? Or sorry, what cancels a logarithm? A base. Okay? Well, it has to be the same base as the logarithm. If this is a log that has a base of 2, then you have to use a base of 2. Now you got to write this carefully. If I write it like that, is that a base? How do you know if it's a base or not? It's going to have an exponent. Okay? If I write it like this, where this is the exponent, then is that a base? Yes. You guys see exactly how I've written that? Yeah. This is the base. That is the exponent right here. But since this is an equation, you've got to do the same thing on this side. I have to use a base of 2, and that's the exponent. You following? Yeah. Exactly. If you have a base of 2 and the exponent is a log base 2, they cancel each other out. So you're just left with 8 equals 2 to the third. And always make sure you have a true statement. Does 8 equal 2 to the third? Yes. So you want to put it here. That's the base. That's the exponent. And over here, that's the base, and that's the exponent. It's not that hard, is it? Let me try this one. Log base 3 of 81. Log base 3 of 81 equals 4. Rewrite that in exponential form.
Log base 3 of 81 equals 4. And then once you have an answer, just make sure that your answer is true. Whatever base and exponent you have, make sure it equals what you're saying that it equals. Okay, turn to the person next to you. See what they got. Quick, go!
So, did we use the base of 3 on both sides?
Yeah.
So 81 equals 3 to the 4th. Okay. Okay, write that topic down. Evaluate your logarithm. Evaluate. That means you're going to look at one and say, yep, that's a good logarithm. Nope, that was a bad one. That one needs a little bit of work. We're going to evaluate it. Just like I can evaluate some of you right now. Yep, you need to spend less time on your phone. Yep, you need to quit sleeping. Yep, you need to take more notes. Now, this is what it means to evaluate something. If I asked you to evaluate the square root of 25, you would all say, it kind of means solve. Square root of 25 is? You just evaluated. What's the square root of 9? 3. You just evaluated. What's the square root of 100? 10. You just evaluated. So you're great with square roots, and you're great with most math operations. 2 times 3 is? So you just evaluated something. To evaluate means give the value, see what it equals. Evaluate a logarithm would be something like, what's the log base 5 of 25? And I know you're not familiar with it, so I don't expect an answer, but that's what this means. You understand? What's the log base 5 of 25? What's the log base 10 of 100? So you got to be able to come up with those. And it really isn't super tricky. A little bit at first, but once you get used to it, it's not that bad. So write that one down. Log base 2 of 16 equals blank. Now I'm going to show you what you would say, well, that's such a long way. Once you get better at these, you'll be able to do them hopefully just as quick as square roots, because most of them aren't that bad. But just so you can get used to the process, here's what you can do. You don't have to do it this way. Since we don't know what it equals, let's just say, well, I don't know. It equals question mark. So far, so good? Now, because it's in logarithmic form, that's why for most of you this is a little unnerving, because you're not as familiar with logarithms. So what if we wrote this entire expression in exponential form? Didn't we just practice that?
Yeah.
So what would this look like in exponential form? Well, you have to use a base of 2, and here a base of 2. So it would be 2 to some power equals 16. So now in that form, it might be a little more clear. That question mark has to be, well, we have to solve it, but, okay, you guys know this. 2 to what power equals 16? 4. So the answer to the original question was log base 2 of 16 equals 4. Okay. Why does it equal 4? Because 2 to the 4th power equals 16. Okay. And that's, isn't 4 an exponent? Technically speaking, 4 is an exponent. Because what do logarithms do? They cancel a base, and what would it give you? It would give you an exponent. So 2 raised, so essentially what question you can ask yourself when you see a problem like this, this is a question you can ask yourself. 2 raised to what power equals 16? And that power has to be 4. Alright? So a problem like this, the one I just mentioned, log base 5 of 25. What would it have to be? 2, right? Again, you can think about this question. What power, because isn't this going to be an exponent? What power do you raise 5? 5 to what power gives you 25? Well, I'll show you that in a second. These I'm designing to be a little bit easier. But do you understand the question I'm asking? 5 to what power gives you 25? Come on, easy one. So that has to equal 2. So quite often they're just very simple. Log base 3 of 27. Most of the time they're not super challenging, just to do in your head real quick. Log base 3 of 27. Got to be 3. Because what's 3 to the 3rd power? 27. Okay. depending on your model of calculator, I'm not sure that every single one of your calculators can do this. Most of them can. So go to your calculator. If you have the TI-84 plus Silver Edition with the updated software, you can do what we just did on your calculator. Here's something, though, that every single one of you needs to make sure you understand and you hear this. This button right here, it's a logarithm, but notice how there's no way to change what the base is. I need you guys to understand this. This log button that you press right here is only one particular logarithm. It's log base 10. There's really a 10 right there that they don't write. It's just like with a square root. Do they ever put that little 2 in there? No, they don't. And it's the same thing with this. This is a log base 10 and only a log base 10. You follow? But if you have the 84 plus, you can hit math, scroll up a few spots to where it says log base. You see that option on yours? If you have the TI-84 plus, it should be on there. If you go to math and scroll up, it should give you a log base. If you hit enter on that, try that again. Come on now, guys. There we go. Math, log base. Now you can change it to a log base 3 of 27. And guess what it equals? 3. Log base 3 of 27 is equal to 3. If your calculator doesn't have this feature, I'll have to show you next time. There's a way to get around it, but it takes a little bit longer. But I think your assembly is supposed to start.